So hello friends, today we will derive the drift velocity. Okay, so let's go. So we know that the force is equivalent to QE. Okay, QE. But here we will taking the Q as a minus of electron. We're taking the charge of an electron. That's why the Q minus E will become Q will become minus C. Okay. Now we know that what is the force is a mass to acceleration. Now if we need to find the acceleration, what we'll do, now so it is clear to all of you. So now this is called acceleration. Now we're finding the drift velocity. Okay, we have the acceleration. Now what we'll do, we know the v is equal to u plus at. Okay, but here v will become vd, u will be u, a will be a, but t equal to r. What is this? R is the tau is the what? Relaxation of time. Okay, so tau is the relaxation of time. Now here will be the tau, and you can eliminate this. There is no rule of this. So the initial value will be 0. And what is acceleration? We found from the equation first. Acceleration is this, and tau will be the tau. So Vd, what is Vd? Vd is the drift velocity, will become this tau. Okay, if we taking the mod Vd as in the mod, it will become positive. Okay, E tau by m. So this is a drift velocity. You proved. Thank you. Okay, look at the whole. Thank you. Hello friends, today we'll find the relation between drift velocity and electric current. So what is drift velocity is Vd and electric current is the I. So we'll find the relation between these two. So here we go. So the charge, we know from the quantization of charge, Q equal to, what is Q equal to? Q equal to N and E. Okay, but here we'll take the volume also include. So what is volume? Area into length. Okay, so this is what a new concept. Q is equal to this. Now what we'll do, time. We know the time is equal to distance by velocity. So the whole, it is a length. Okay, it has a length L, so that's why the length will be the distance, and speed, which is the actually in which is a velocity. Okay, so velocity will be Vd, that is the drift velocity. Okay, so this is a time and distance formula. Okay, it is very sure and very simple. And we know the I, like I is equal to Q by T. Okay, here Q is equal to, from this equation, NALE. What is T? T is the L, and this will go to the V upside. So from these two equation, putting these two equation in this, we will getting our answer. So here is L, we'll cancel the L, and here we left A, EA, BD. So I is equal to this. Okay, this is the relation between, so this is the relation. Actually it is proportional to Vd. Okay, electric current. This is the relation, and this is the formula we form. I equal to N AE Vd. Okay, E is the electron, A is the cross-sectional area, N is the number of electrons, Vd is the drift velocity, and I is the electric current. So just look at the whole equation and I am done. So hello friends, today we'll derive the resistance in series. If the resistors are connected in series, then what will be the equivalent resistance? So this is gonna we'll find. Okay, so we need to derive this. R is equal to R1 plus R2 plus R3. Okay, so let's go. We know from Ohm's law, like from Ohm's law V is equal to IR. Okay, V is equal to IR. So what we'll do, we'll take the potential difference here, A, VA, VB, VC, VD. So from BA to VB, we have I equal to IR. Okay, take this is question 1. From BV to VC, we have IR2. Take this as equation 2. From VC to VD, we have IR3. Okay, and take the whole once from VA to VD. Okay, so from VA to VD, we have I equal to R. Okay, this is the last equation. And now what we need to do, we need to add 1, 2 and 3. So add. So when we are adding it, so V will get cancelled, minus C will get cancelled, and we left with VA minus VD equal to I R1, I R2, I R3. So take this common, I will be the common, and R1, R2 and R3. Okay, and we know from the equation 4 where IR VA to VD is equal to IR. So put IR here. So I will get cancelled, and R is equal to R1 plus R2 plus R3. So done. It's proved. Okay. Thank you. Hello friends, today we'll derive the Joule's law. So the heating effect of current, which is the Joule's law. Okay. So here this is what we need to derive. H is equal to I square RT. So we should know this. Okay, the potential difference is equal to work done by Q, charge. Okay, and work done is equal to what? V by V into Q. Take this as equation 1. And from Ohm's law I equal to VR, equation 2nd, and we know Q is equal to IT from the definition of current. Now what you need to do, you need to put the equation 2 and 3 in equation 1. Okay, when you put, you will get IR into IT. Okay, so it will become I square RT is equal to W, and we know work done is converted into heat energy. Means there is neither the energy can neither be created nor be destroyed. So work done is converted into heat energy. So instead of W, we can write H is equal to I square RT. Okay. Thank you. So hello friends, today we'll derive the parallel resistance, equivalent resistance of parallel. Okay, if the resistors are connected parallelly, so what will get the equation? So it will get 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is what we'll go to derive. Okay, this is what we'll go to derive. So before we derive, we should know if I current is passing through, I will divide into I1, I2, I3 respectively, R1, R2 and R3. Okay, so I is equal to I1 plus I2 plus I3. Okay, and from Ohm's law we can say I is equal to V by R. Okay, where from Ohm's law? Okay, from Ohm's law. So if we're taking I1 V by R1 will be this. Okay, take this as equation 1, take this as equation 2. So I2 will be V by R2 and I3 will be V by R3. Okay, so put equation 2, 3, 4 in equation 1. So what we'll get? I equal to V by R1, V by R2 and V by R3. Now what we'll need to do? What is I? I is equal to V by R. So write V by R. So V by R1 is equal to V by R2 is equal to V by R3. So V will get cancelled. Now 1 by R is left with 1 by R1, 1 by R2, 1 by R3. So this is a parallel resistance form. Okay, so this is all about. This is proved. Okay, thank you. Hello friends, today we will find the microscopic form of Ohm's law, or we can say it vector form of Ohm's law. Okay, what is the vector form of law? So we'll taking it the cylinder which has the L plane and there is electric field involved. So let's go. So we know that the electric field E equal to V by L. Okay, the potential difference to the L. So here V will become EL. Okay, so take it as equation 1. And we know V is also equal to IR. Okay, V is equal to IR. From Ohm's law we have V is equal to IR. Now what we'll do? We'll put R value, like R is equal to resistivity L by A. So we'll put, instead of R we'll put rho L by A. Rho L by A. This will be the equation 2. Okay, the equation 2. Compare. We know V is equal to this, so first equation, second equation will be equal to each other. So EL is equal to I rho L by A. So L will get cancelled, and now we'll left with this E equal to I by A rho. So before going to solve this, we should know conductance. What is conductance? Conductance is equal to 1 by R. It is reciprocal to the resistance. But we will if we consider the conductivity, it will reciprocal to resistivity. Okay, and the current density. The current density is this, J equal to I by A. This is the current density. We'll use this and we'll use this, the resistivity form. So here we can say Ij equal to what? Ij equal to I by A equal to J. Okay, and rho, and this is electric field. Okay, So what we can say, resistivity is equal to 1 by 1 by conductivity. Okay, so E equal to J 1 by conductivity. So we know this is in vector form, this is also in vector form. So J equal to conductivity into electric field. So this is our final answer. Okay, this is our final answer. So look at the proper equation. Thank you. Hello friends, today we'll know about the Kirchhoff's law. Okay, the Kirchhoff's law of the first law of Kirchhoff's. Okay, so the first law is also known as the first law of Kirchhoff's is also known as junction law or KCL. Okay, so what it states that the sum of all currents entering any point, either junction, must be equal to the sum of all the currents leaving that point. Means the sum of all currents entering is equal to the sum of all currents leaving. Like this is a example. Okay, this is an example, and this is example. If I1 current is entering with I2 current, so I1 I2 current is entering here at this is called at a point, or this is a junction. Okay, where all the lines meet is called junction, and it is that point. Okay, so I1 and I2 is entering, and I3 is leaving current. Okay, I1 I2 is leaving. So what we can say here, I1 equal to I2 equal to I3. Okay, why? Because here these two current entering equal to current leaving. Okay, so that is what. So now we need to what we should need to take. So I will shift here, this will be this. Okay, so it will become the summation of I equal to 0. Okay, this is the first law of Kirchhoff's law. Kirchhoff's first law. Okay, so it is also known as junction law, and this is it. So we'll moving to the so it is also based on the law of conservation of charges. It is based on the law of conservation of charges. Okay, what is law of conservation of charges here? So in the previous we know I1 plus I2 is equal to I3. Now multiply in both sides with time t. So IT plus I1 IT equal to I3 into I3. Okay, I3 into t. So it will become Q1, it will become Q2, it will become Qt. From the definition of current, Q is equal to IT. Okay, that's why it will become this. So Q1 plus Q2 plus minus Q1 Q3. So it shows it is based on the first Kirchhoff's law is based on the conservation of charges. Thank you. Hello friends, we will derive the Ohm law using the concept of drift velocity. So we know E equal to, what is the electric field? E equal to V by L. Okay, and what is the relation between current and the drift velocity? So this is from the relationship between the current and drift velocity. This is formula. Okay, so and we also know that the VD, the drift velocity, is also equal to electron into electric field relaxation of time into divided by m. So 1 2 3, through this equation we'll finding our answer. Okay, so let's go. So here we can say if we if we put our answer Vd, okay, take it as an equation, okay, this would be the equation 1, this would be the 2, this would be the 3, okay, put equation 3 in equation 2, okay, so what we'll get, NEA E tau by m, okay, and we know, and also put equation 1 in this equation 2, okay, so you will get E square A, so E is equal to what? E is equal to V by L, okay, so here we'll write V by L Lm tau, okay, so this is a equation. Now what we'll do, we know I is equal to N square E square A V tau divided by ml. So what you need to do, you need to shift the value, as we know here is V and there is I, so V by I equal to ml by N square A tau, okay, so what is V by R? V by R is nothing, it's resistant, okay, V by R is the resistance, so we'll put the value here, so it will become R is equal to ml divided by Ne square A tau, okay, and well, this take this as equation 4, so we know rho equal to resistance equal to rho by A by L, so take it 5, okay, equation 5. Now what you need to do, okay, what you need to do, compare the equation 4 and 5, okay, compare equation 4 and 5. If you comparing these two equations, if you separate this, okay, first of all separate, this is L by A and this M and E square tau, this is the another, now L is equivalent to L, A is equivalent to A, but rho is equivalent to which? Rho is equal to M divided by Ne square tau, the relaxation of time. So we proved it. Thank you. Look at the whole equation. It derives from this and this too. Yeah. Also, lastly we had this. So hello friends, today we'll know about the Kirchhoff's second law, okay. So it is known as loop law, okay. It is known as loop law, which is also KVL, okay. And what is means it and what it states. So it is stated that the algebraic sum of all the voltages, the potential difference across all the elements, and EMF of all sources in any closed electrical circuit is 0. What it means to tell? It means to tell the sum of EMF and the potential across all the elements, this is a potential in a closed circuit, okay, will be the 0. So this is what it means to say, okay, this is what it means to say, and let's know it better from a question. So before we know, it is based on the before we solve, we know it is based on the law of conservation of energy. The Kirchhoff's first law is based on the law of conservation of charge. The second law of Kirchhoff's is based on the law of conservation of energy, okay. It is also known as loop law because it is happen in the closed circuit, okay. So we need to make a loop. So I'm taking it as this. Okay, go from here to here to here. So let's see, I current is passing through this. Okay, we are letting this. So it will become -2 if the current is going through the my drawn arc line. So it is like this. So we'll take minus if current and my drawn arc will be opposed to each other, so it will be plus. Okay, so through this assumption we can go. So it will be 2i, and it is going to where? It is going to again minus point is here, current is leaving from here, so it will be again minus 1.5, and this is going to this. Okay, so this will be this will be minus, no, this will be the plus 3. So sorry, this will be the minus 3. Okay, minus 3, this will gonna be plus because so this, the I is going through this, so and this is also a minus, this is also the plus, and this is going to the positive axis at finally, like if we moving from this, so this at last it has a minus and this is plus, so we'll taking it as plus. Okay, plus 3, and now it equal to 0, according to the law of conservation. So 5 minus 5i plus 4.5. Okay, no, it's 4.5, it's 1.5. Okay, so I is equal to 5i is equal to what? 1.5, and I is equal to 1.5 into 5. It will become 0.3 ampere. So that's it. So what we did, we taking loop as this, and we know it is coming past to a minus, that's why I choose the minus sign, and this is going to the positive side, that's why I choose to make plus sign. Okay, this is plus and this is minus. Okay, and you know the concept I told you, if the resistors. Okay, so take the look in both. Thank you. Know the formula of meter bridge. Okay, and what's the condition here applied? Okay, so from Wheatstone bridge we know the P, if the ratio of P by Q and R by S is equal, that means there is no current flowing through their middle. Okay, so we'll apply the Wheatstone bridge, and also we should know this length, the whole length is 100. Okay, so if this length is L, so automatically this length will become 100 minus L. So P and Q is the resistance, and R and S also the resistant. Okay, and Q here, G is the galvanometer, detector. Okay, and it is detecting, and this is a potential, this is a V, voltage. Okay, and this is a switch. Okay, so this is the figure all about. So we are going through. Okay, going through the steps. So we know from Wheatstone bridge, P by Q is equal to R by S, like P by Q by RS from Wheatstone bridge. Okay, so and here P is equal to L, RL. Okay, what is L here? L is nothing, just it is the resistance per unit length. Okay, resistance per unit length. And what is Q here? Q will be r into 100 minus L. Okay, so put P and Q here. So put P and Q here. So we have R by S equal to RL by 100 minus L by R. So RRL will get cancelled. So we're left with now to change the denominator and numerator. So it will be 100 minus L by L. Okay, it is done. But we need to find the S. Okay, because we need to find the S. So which is the resistance. So S is equal to 100 minus L by L into R. That's it. In this you will find the directly numericals. The numerical will give the R value, L value, you need to find the S. Okay, the resistance. So this is it. So this is it. Hello friends, today we'll know about the sensitivity of a potentiometer. It is the smallest potential difference that can be potentially accurate measure by gradient potential is known as the sensitivity of the potentiometer. Means it will give the smallest value of the potential difference, okay, which is the accurate and which is measured by the potential gradient, okay, and this is known as the sensitivity of the potentiometer. So here we go. So this is our image. This is the first, this is the second connection through the switch. Here is the switch, and this is a jockey, gives the direction through the galvanometer. This is also another key. This is the resistance, and this is all about ammeter, and here we have the potential difference V, okay, and here I is passing through. So let's go. So we should know the EMF, which is I1, okay, the I1 E1 is proportional to L1 and E2 is proportional to L2, the length, okay. So E1 by E2 will be equal to L1 by L2. This is the first formula we get. And also we can know if from this image, like if there is a EMF E, okay, let's say there is a EMF E, okay, and which is proportional to L1, and here is the potential difference which is proportional to its length, okay, P is proportional to its length of second, so it will be V1. Now take it as divide it both. When you divide it both, it will become L1 by L2. Okay, this is the second form. Okay, so we know R, the relation between EMF and the potential difference is equal to this, okay. This is the internal resistance, this is the resistance, this is the EMF, and this is the V. So from previous equation, take this equation as 1, take this equation as 2, okay, sorry, take this as 2 and take this as equation 1, okay. Now compare this. Well, instead of E by V, we can write R is equal to, okay, R is equal to L1 by L2 minus 1, and this is our formula. We generate the formula. So thank you. Hello friends, today we'll solve the problem of Wheatstone bridge, okay. So we need to prove what we need to prove. We need to prove P by Q is equal to R by S. Okay, R by S. So this is what we are going to derive. So what is P? P is the resistance, Q is the resistance, R is the resistance, S is the resistance. So and G is also the resistance. So what is the condition? Okay, if the ratio of P by Q is equal to the ratio of R by S, then there is no current flow. Means we'll going to take Ig will be 0, but not now. So let's go. So before you should know the diagram. This is R, this is S resistance, this is P, this is Q, this is P resistance. Okay, so I current is traveling and it is split into two, I1 and I2. Okay, I1 through R resistance, I2 through P resistance, and Ig. There is a downward Ig is go to the G resistance. Okay, and which is a galvanometer, and here is going I2 minus Ig, and here is going I1 plus Ig, and in return I will be out. So if you add these two, like I2 plus Ig, I1 plus I2 Ig, if you add this to this one will cancel, and I1 I2 will be left. And what is I is equal to I1 plus I2. Okay, so where I was, if in returning we giving I, we'll taking it back I. Okay, that's simple. So go for it. Look at this loop. Okay, do not see this two. We are working on this. Okay, this loop. So here we go. So I2P is equal to, if we take it as a loop. Okay, so I am drawing a loop. So I2P is equal to Ig. Okay, and it's equal to IR. Take this as equation 1. And now don't think this is exist. Okay, now go for this. I'm taking the loop here, and the QI2 Iz. Okay, is equal to I1 plus Ig into S. And also Ig. Okay, this is it. So we'll take the first loop as a equation 1. Okay, invisible this area, and invisible this area, and we'll have this area, this part. So we're doing with the loop. Okay, so this will be the second. Now what we'll do, now here we're coming to the point. Take Ig is equal to 0, because if this ratio and this ratio will be equal, then there is no current flowing, there is nothing. Okay, so this is known as Wheatstone bridge. Okay, so Ig is equal to 0 from equation 1. If Ig equals to 0, so I2P is equal to I1 equal to this. Okay, so here I1 by I2 equal to P by R. Okay, take this equation 3. Now Ig 0. If Ig 0 in the second equation, so I2Q is equal to I1 S. Now from here take I1 by I2 is equal to Q by S. Now what you need to do, now we know I1 I2 is equal to I1 P by R is equal to Q by S. So go for it. So equate this. Okay, from equation 3 and 4 we have PR equal to QS. Okay, so what we'll do, we need to make in this form. So cross multiply it. So P by Q is equal to r by s. So done. We are done with it. So this is it. This is a Wheatstone bridge derivation. Okay.